Alright, this is our third video on the Test 3 review. Hopefully this will be the last. I think I can get it finished here. It says a painter can finish painting an apartment in 5 hours. His assistant takes 7 hours to do the same job, so he's not as quick. How long would it take for them to complete the job together? So we're going to let x equal the number of hours they work together to get the job done. And what we learned is in X hours, the painter does the work, or I should say he does X fifths of the work. Like for example, in 1 hour, he would do 1/5 of the work since he does it in 5 hours, the whole job. So in 1 hour, or in X hours, he would do X fifths, 1/5 if it was an hour, X fifths if it was X hours. His assistant would do X sevenths of the work in X hours, and we want this to be 1, which represents the whole job. So that's how we set this up. We discussed how to do that in class. Now, our LCD here is going to be 35. There's only two denominators, 5 and 7, and the LCD for that is 35. Oh, excuse me. So we're going to multiply everything by 35 here. Don't forget to multiply the 1 by 35. Here you're going to get 7x plus 5x equals 35. Add these like terms, you get 12x equals 35. We're going to solve for x by dividing both sides by 12, and we get 35/12. Now remember, x is the number of hours that it takes them working together here to complete the job. How many 12s go into 35? Well, if it was 36, you would have 3, but here there's just 2. And 35 minus 24 would be 11, and so that's 2 and 11/12 hours. All right, on number 17, this will be 10x to the 4th over 2x squared plus negative 4x cubed over 2x squared plus 12x squared over 2x squared. So we'll basically take each term of this trinomial and we put it over 2x squared. This is how we handle division by a monomial, where we have just one term in the denominator. Well, we know that 10 over 2 is 5. And x to the 4th over x squared, we subtract the exponents, we get x squared. Notice here we have plus a negative number, because this is a negative divided positive, so we'll write that using subtraction. 4 over 2 is 2, and x cubed over x squared, 3 minus 2, we're going to get x to the 1st, or just x. And then finally, notice the x squareds cancel here, and 12 divided 2 is 6, so we'll get plus 6. So 5x squared minus 2x plus 6 is our final answer. All right, so next we're going to do long division, and we learned that we set it up very similar to what we do. Actually, let's move this over just a bit. When we normally divide numbers. So we have, oops, I'm putting things in the wrong place. This is 6x cubed plus 17x squared minus 27x plus 16 divided by 3x plus 4. So we ask ourselves, what times 3x is 6x cubed? Well, that would be 2x squared. And then we're going to multiply the 2x squared times our divisor here. 2x squared times 3x is 6x cubed. 2x squared times 8. I'm sorry, 2x squared times 4 is 8x squared. Now we're going to subtract this from what's above. Now the other way we do this is we can just change the signs and add. Because when you subtract what's here, it's the same as adding the opposite. So change your signs and add. But I'm going to do it this way. 6x cubed minus 6x cubed is 0, which is what we expect every time. Then we have 17x squared minus 8x squared. That'll be a 9x squared. And let's go ahead and bring down the minus 27x. I need two terms here because I have two terms here. Okay, so let's go ahead and do the same thing. We got to figure out what times 3x gives us the 9x squared here. We're just looking at the leading terms. Well, that would be a positive 3x, so we'll write plus 3x. 3x times 3x does give me 9x squared. These should be the same. 3x times 4, that's 12x. So again, I could do it the way I did up here. I'll do it the way we've been doing it with this group. We're going to change that positive to a minus and this positive to a minus. So these guys add up to 0, which is what we expect. Negative 27 and a negative 12. Let's see, that's going to be a negative 39x. And then don't forget to bring that plus 16 down. Again, I need two terms here in order to, because I have two terms over here. All right, so again, we look at the leading terms, and 3x times something is negative 39x. That'd be a minus 13. So we'll multiply negative 13 times 3x is negative 39x. And negative 13 times 4 is going to be a negative 52. Remember, we can switch the signs here and add, so it'll be negative 39x squared and a plus 39x, not x squared, but just x. These terms, negative 39x plus 39x, that's going to be 0. 16 plus 52 is 68. So finally we're ready to give our answer. The quotient, which is the answer to a division problem, is 2x squared plus 3x minus 13. And then it'll be plus our remainder, which is 68, over our divisor, which is 3x plus 4. So remember, it's the quotient plus the remainder over the divisor. That's how we write our answer. In my math lab, they may just ask you, what is the quotient? What is the remainder? And normally that's all you're going to have to give. All right, we're on the last page. All right, on number 19 here, we're using synthetic division, and we learned that when we do long division, we end up doing subtractions and divisions, and it's just easier to do multiplications and additions. And we basically get rid of all the x's, and we've got this real simplified way to do the divisions we were doing before. Although the last problem we did, we wouldn't be able to use synthetic division because this is not a 1x. There is a way to adjust for that, but we didn't get into that. So the fact that this is linear, it's x to the first, and it's a 1x is what makes it possible for us to use synthetic division. So we're going to put a little box here, and we're going to put the opposite of what's here there. That would be negative 2. And so our coefficients here are 5, 2, negative 1, and negative 4. We're going to drop the 5 down, and then we're going to do what I call the multiply, add, here. We're going to go back and forth, multiply, add, and so on. So multiply here, you get -10, that goes here. In the columns, you always add. -10 and 2 is -8. Then we're going to multiply, we get 16. We're going to add, we get 15. We're going to multiply, we get, what's that, -30. We add, we get -34. Okay, so we also need to make sure we know how to write our answers. Since we're dividing a cubic function by a linear function, our degree will drop 1. So this 5 will represent 5x squared, and then it'll be a -8x. We'll just keep dropping by 1 degree, plus 15. This number here should always be your constant, and notice it is. Plus we do have a remainder, so it'll be plus -34 over our divisor, x plus 2. Now keep in mind, we could have written this as minus 34 over x plus 2, but either of those are fine. In my math lab, they might require you to put in a negative there. All right, I want you to notice on B, we're missing the x cubed term. One of the things we talked about how important it is that things lined up correctly when you're doing division, and that's true with any kind of division. And so we need a placeholder for our x cubed terms. So we're just going to write 0x cubed here. This is what I like to do. We're going to put 3 in the box. Remember, it's the opposite of the sign that's here. And so then it'll be 4 and then 0, -3, 2, and 3. If you don't put a 0 in here, your answer will be different. It's got to be a 0 there. Again, what we're really doing is putting in a placeholder so we have a place to put any of our x cubed coefficients. Okay, so let's drop the 4, and we'll do our multiply add here. 3 times 4 is 12. In the columns we always add, so here we get 12. 3 times 12 is 36. When we add, we get 33. Multiply, we get 99. When we add, we get 101. Multiply, we get 303. And when we add, we get 306. That's a big remainder. So we have a 4th degree polynomial dividing by a linear polynomial, so our degree drops 1. Our answer will be, our quotient will be 4x cubed plus 12x squared. Just keep dropping your degree by 1, plus 33x plus 101. Notice again the 101 is my constant. That's what I expect. If it's not, there's a problem. Plus our remainder, which is 306, over our divisor, which is x minus 3. All right, let's go ahead and do problem C. You may want to try it first and then watch my work here. So notice there's no x squared term and there's no x term. And so we're going to have -3 in the box, the opposite of what's here. Our coefficients are going to be 1, and then 0, 0, and then 27. We'll bring down the 1. When we multiply, we get -3. When we add, we have -3. We multiply, we get 9. When we add, we get 9. Multiply, we get -27. When we add, we get 0. So notice here we have a quotient with no remainder. So this is cubic. We're going to drop our degree 1. It's x squared minus 3x plus 9. And in fact, we know that if this divided by this equals this, then when you multiply these, you get x cubed plus 27. We learned how to factor this. It actually does factor into x plus 3 times this quotient that we just got. Hopefully you saw that. All right, we have one last section to do here. Actually, two more problems. On problem 20, we're let's see, we're going to basically solve for the variable that we're requested to solve for. So here that would be x. So I want to get x by itself. Well, since I have a proportion here, I think the first thing I would do is cross multiply and set these equal. So xy is equal to wz. It doesn't really matter which way you go first, but since I'm solving for x, I thought it'd be nice to keep x on the left. So to get this solved for x now, we just need to get rid of this y. Let's divide each side by y since it's x times y. The opposite of multiplying by y is dividing by y. We get x is equal to wz over y. All right, on part B, we're supposed to solve for a. Now, in this problem, we don't have a proportion like we did here, so we can't cross multiply. But what we could do is find our LCD. Well, there's two denominators and they're both algebraic, so we'll just multiply them together. And so I need to multiply each term by AB. So when I multiply AB times T over A, my A's are going to cancel. And I'm left with B times 1, or just B. When I multiply AB times, oh, I forgot the T, I'm sorry. This is not a 1, this is a T, it's B times T. And you have a plus, and the B's here cancel, and you're left with A times T. And on the other side, you have AB. Now, if you're trying to solve for A, you've got a problem here because A is on both sides. I need these two terms on the same side. So I'm going to subtract AT from both sides. I have BT equals AB minus AT. Notice these are not like terms. All I can do is write the first minus the second. Now I have the ability to solve for A, but you've got to notice, first of all, that I need to factor out a GCF of A here. So this is A times B minus T. So finally, if I want to solve for A here, I've got A times B minus T. The opposite of multiplying by B minus T is dividing by B minus T. Now, because I'm going to cancel here, I did put that in parentheses. You don't really need the parentheses over here. But we're going to end up with BT over B minus T. That's what A is equal to. So A equals BT over B minus T. Now, if you put this in the opposite order, that's not important, but that's what you should get for A. All right, we've got one more problem. This is an optional problem, depending on which course or which class we're dealing with here. So this may or may not be a problem you have to do on the test, but I'm going to go ahead and do it anyway, so if you at least tried it, you can see how you did. All right, so we did these kinds of problems using 3 steps. This is called the difference quotient, and this is what we're finding when f of x is x squared plus 3. So first of all, we find this piece here, f of x plus h. Well, we're just going to replace this x and this x with x plus h. So it'll be x plus h squared plus 3. So the x here becomes x plus h. And the x here becomes x plus h. And notice it's squared. you need the parentheses here. So you're going to have to FOIL this. It's going to be x plus h times x plus h plus 3. And when you do that, you end up with x squared plus 2xh plus h squared plus 3. You can FOIL it off to the side if you need to, but you should end up with these three terms. And when you add 3, there's no like terms here, and so we're done. So second step, now we're going to focus on the whole numerator. It'll be f of x plus h minus f of x. Well, we just found f of x plus h. And we're going to subtract f of x. Now f of x is a binomial, so we need parentheses here. So notice this is f of x plus h minus f of x. So we can rewrite this part and distribute the negative here. We get a minus x squared and a minus 3. And something useful happens here, and this is something that you will see quite common. The two terms that were here that were part of f of x end up canceling with terms that are over here. Notice the minus x squared and the plus x squared, the 3 and the minus 3. So notice what's left. You have 2xh plus h squared. So finally I'm ready to put this all together, and I'll have the difference quotient. F of x plus h minus f of x all over h. Well, we just found the numerator there. It's 2xh plus h squared. Our denominator is h. So we can break this into two fractions. Here the h's cancel. You get 2x, h squared over h. 2 minus 1 is 1. You get just plus h. And that's going to be the answer there. All right, that's it for this review.